Hello, I welcome you to our 60th class in biodiversity conservation. And in today's class, we want to look at a very important metric, which is known as important value index. So the focus of our class is to look at one way of evaluating biodiversity or species composition in an ecosystem. And one metric that we use is known as Important Value Index. And the acronym is IV, IV. Okay, so this is what we want to look at in today's class. So to start with, how do we define IV or Important Value Index? Well, IV is defined as a metric for evaluating the relative importance of species in an ecosystem. So we are saying that an ecosystem will have biodiversity, we have different species, okay? And how do we know which of the species is important or is relatively more important than the other, and which one is the least important than the others? It's important to know this as the course unfolds. We'll see why it's really, really critical that we know which value is important or which species is important. So to help us come up with an important value index or an index that measures the relative importance of species in an ecosystem, we have three parameters that are used in IV. The first one is called the relative frequency, RF. So the relative frequency focuses on evaluating how often or which of the species is frequenting more than the others. So that is a relative frequency. Then we have relative density. Relative density, we are looking at the abundance of species relative to the size of an area, okay? So here we want to see how densely populated that species is relative to all other species. And then we have another parameter, which is known as the relative dominance, with an acronym of RDO, where R is relative and DO is dominance. This one measures the basal area of species in an area so that we know how much of space or how much of an area is covered by that specific species. So in today's class, we'll look at these three parameters or variables, and we'll calculate or we'll try to evaluate how we can actually estimate these values for us to come up with this index known as the important value index. So always remember that three important variables or parameters are calculated in important value index. The first one is relative frequency. The second one is relative density, and then we have relative dominance. I love mathematics. Life is about mathematics. So if you can't add numbers and if you cannot interpret those numbers, then it's important for you to reach the pinnacle of your profession. Okay, so if you want to sit at the top of your profession there, you should be able to evaluate numbers, not just defining, writing an essay. No, you should be able to come with numbers and then make sense out of those numbers. And then you can be impactful in your profession. When I was growing up, my mathematics teacher told me that if I want to become a soldier, why should I focus on numbers? Well, becoming a soldier is numbers. You need to know numbers. For example, in your magazine, the gun has got a magazine where you put bullets. If you load your magazine with 5 bullets, right? and then you are in the battlefront. You have 1,000 enemies approaching you, and all these enemies are armed with a lot of ammunitions. Well, you need to calculate 10 versus 1,000. The best way is to surrender. Okay. If you're a mother at home, you need to work with numbers. How many people are at home? It's a family of 4. It's a family of 5. Okay. How much money do I need for groceries, to buy relish? Okay, I need 2,000 kwacha, or is it 5,000 kwacha? Okay, will it be enough to sustain that number, that population? Yes, it will be enough. What if during the holidays we receive in-laws, we receive visitors? Do I have any contingency plan? Maybe there's an extra 1,000 kwacha to do. So life is about numbers. If you're a bachelor and you want to marry, you need to calculate how much do I earn? Okay. Is my job good enough to support a woman, a wife? If it's not, then it's better to remain a bachelor. So life is about numbers. And if you go into any exam, if that exam doesn't have numbers, it doesn't have calculations, then that exam is not prepared by Lembani. I want my students to be able to work with numbers and make sense out of numbers. So here is how we work with numbers. For estimating relative frequency, we said that relative frequency is based on the number of plots. So we want to know how many plots are we looking at, okay? And we need to divide the number of those plots, or the number of species found in those plots, by the total number of plots. So in the notes that I shared under Appendix 1, I shared this example of 5 plots, okay? So you are sampling these species in 5 plots. And each plot has got species composition. So in plot number 1, we have species A. We also have species B. In plot number 2, we have species A and we have species C. In plot number 3, we have species B and we have species C. In plot number 4, we have all the species. We have species A, species B, and species C. And in plot number 5, we have species A and species C. These are the species that are found in these 5 different plots. Okay. Now a question is, determine the frequency for each species and the sum of species. That was the question I asked. And then the second question is, calculate the relative frequency for each species. So the ultimate goal of this question is for you to evaluate parameter number 1 of those 3 parameters under the important value index. So how do we go about calculating the relative frequency? The first thing is we want to count how many species we can find in every, in that area across all the 5 different plots. So if I'm to get my pen there and just count. So in plot number 1, we have species A, okay? So we focus on one species at a time. So in plot number 1, we have species A, so that's 1. In plot number 2, we have species A again, which is 1. So we have 1. In plot number 3, we do not have species A, so we skip that one. In plot number 4, we have species A1, so we have 1. In plot number 5, we have species A. So how many species A's do we have across the sampling site? So we have site and plots. So plots are subsets of the site or an area. So in the entire site, we have 1, 2, 3, 4. So species A is appearing 4 times. So we say species A is equal to 4. What about species B? Species B, in plot number 1, we have species B appearing once. In plot number 2, we do not have species B. In plot number 3, we have species B appearing once. In plot number 4, we have species B appearing once. In plot number 5, we do not have species B. So if we count all the species in the site, we have 1, 2, 3. So species B is appearing 3 times. So we say species B is equal to 3. In plot numbers, for species C, in plot number 1, we have no species C. In plot number 2, we have 1. In plot number 3, we have 1. In plot number 4, we have 1. In plot number 5, we have 1. How many species C we have across all the 5 plots? We have 4. Okay, so this is how we are counting the number of frequency or determining the frequency for each species. Okay, so we've answered partly number 1, determine frequency for each species. So for each species, we have 4 for species A, we have 3 for species B, and we have 4 for species C. That is the frequency of each species. What is the sum of the species? So we are saying what is the sum? We are basically adding the total number of individual, candidates or individual, species in this sampling site or across all the 5 different sites. So we are saying we add species A, how many we are having in species A, species B, and species 3. In other words, what is the population? So the population will be 4 plus 3 plus 4, which gives us 4 plus 3 is 7, right? Then 7 plus 4 is giving us what? Is giving us 11. So we are having a population of 11. So the sum of species is equal to 11. So we've answered step number 1, the number of each species. Okay, we go to number 2, step number 2, number of plots. So what number or what is the total number of plots that we are getting here? So we are saying that the total number of plots is equal to 5 plots because we have 5 plots. We've got plot 1, we've got plot 2, we have plot 3, we have plot 4, and we have plot 5. Okay. So we have 5 plots. So now, under step number 2, we are saying what or divide each species by the number of plots. So we know that for species A, we have 4 species, okay? Or rather species A, we have 4 different individual population, okay? So we are saying that we divide that 4 by the number of plots, which is 5. So 4 divided by 5, if you've got a calculator, 4 divided by 5. Okay, so I'm just looking at a message that's coming from a student where I clearly indicated to say, submit your assignment to to my email address, and I provided the email address. And then this student dumps the assignment into my WhatsApp group, okay? So now I said, you cannot dump this here, follow instructions. So students lose marks just because of failure to follow instructions. And I don't understand this behavior where it comes from. Just simple instructions, students will not follow that. They just want to do their own things. And I'm very aggressive when it comes to this. You lose marks. And some students fail because of failure to follow simple instructions. Okay, so we are looking at species A, where we are saying we have 4 population divided by the number of plots, which is 5. So if you divide 4 divided by 5, so we are getting 0 0.8. Okay, for species A. For species B, we are saying we have how many population falling under species B? We are saying we have 3. So it will be 3 divided by the number of plots. So 3 divided by 5, which is giving us 0.6. I hope you are following through. You need to calculate alongside me so that you are not lost. For species B, for species C, we are saying we have 4/5, which is again giving us 0.8. So 4 divided by 5, it's giving us 0.8. Okay. Now we are saying calculate the total frequency. So the total frequency across all the 3 different species, we are saying that the frequency for species A, species plus species B plus species C. So we are saying 0.8 plus 0.6 plus 0.8. So if we add 0.8 plus 0.6 plus 0.8 for species C, it's giving us a sum of 2.2 as the total frequency. So that is the total frequency. Okay. So under step 3, we've added the frequency for species A, which is 0.8, and then the frequency for species B, which is 0.6, and the frequency for species C, which is 0.8. So 0.8 plus 0.6 plus 0.8 is giving us a total frequency of 2.2. I hope you are following. Okay. Now, the final answer is calculate the relative frequency. So for each species, relative says that how does this frequency for this species relate to other species? Okay, so we start with the species A. What was the frequency for species A? We said that it's 0.8 divided by the total frequency, which is 2.2. Okay, so 0.8 for species A divided by the total frequency of 2.2 is giving us 0.3636 times 100. Remember, the formula is frequency for the first species divided by the total frequency. Okay, times 100. So we are saying 0.8 of species A divided by 2.2 as a total frequency times 100. So we have 0.8 for species A divided by 2.2 times 100. Okay, because it has to be calculated as a percentage. Times 100. So for species A, we have a relative frequency of 36.36%. I hope you are not lost. The relative frequency for species B, we do the same. Okay? We calculated the frequency of species B to be 0.6 divided by what? The total frequency of 2.2 times 100. So we are saying it's 0.6 divided by 2.2 total frequency times 100. We are getting 27.27%. That's the relative frequency for species B. The relative frequency for species C, we are saying the frequency of species B is 0.8 divided by what? Divided by the total frequency of 2.2 times 100, which is giving us a relative frequency of 36.36%. Okay, so to answer question number 2, calculate the relative frequency for each species. So we'll say, therefore, species B, or the relative frequency for species B, is equal to 36.36%. The relative frequency for species B is equal to 27.27%. The relative frequency for species C is equal to 36.36. Those are the relative frequency. So we've calculated the relative frequency for the species. I hope there are no issues. I hope there are no issues. Okay. So if you have any problems regarding calculation of relative frequency, please use our WhatsApp group or our Google Classroom to share your concerns, and then we can provide more clarity. But as it is, if you've gone through these calculations, it should be very, very easy for you. Okay. So we want to move over from the first parameter and go to the second parameter. This will not be considered here. Okay. Students. Yeah, apologies for that. We are getting some disturbances from students. Yeah, so I can be very brutal when a student doesn't follow instructions. I am very brutal. As long as a student is following instructions, you can even take me for ice cream or to go and drink Mosi, or is it Black Label? Yeah, we'll become friends. So you follow instructions, you become friends with Rembani. You do not follow instructions, yeah, you would be like, but I bought him more ice cream the other day. What has changed? Yeah, what has changed is that you are not following instructions. All right. Yeah, remember we are teaching students who should be able to be disciplined. We want to send, professionals, graduates who are very disciplined. They can follow instructions, they are punctual. Besides being meticulous with their work, if you are not dependable, you are not punctual, you cannot, deliver or follow instructions to the letter, then even your capabilities is nothing, Yeah. Relative density. So relative density, basically, we are talking about the abundance of species or space that is available to every individual's, species. So we tend to calculate the population of people living in a specific area, okay, according to the population density. For instance, if we want to calculate the population density for Lusaka, we need to know the size, the area extent, okay, the size of Lusaka. And then we also need to know the population of Lusaka. Then we use the formula of population density is equal to area divided by population. Then we will know how much of space on average is allocated or may be allocated to an individual, to every individual in Lusaka or in Kitwe. For example, Lusaka has a size of 21,986 square kilometers. That's the total size of Lusaka province. 21,986 square kilometers. And it has a population based on the last census of 3,079,964. So the question is, how do we calculate the population density? How much an area should every individual be entitled to, assuming that every individual is given a portion of land. Okay? So we are saying the population or the total area of Lusaka divided by the population. So we have 21,986 divided by 3,079,964. If we divide that, we will get a value of 0.007 square kilometer per person. So take away the fact that there's a, Heroes Stadium, there's Woodland Stadium, there's, East Park Mall, assuming that it's only people. And if every individual living in Lusaka was allocated a plot, every individual will be given a size of about 0.07 kilometer square per person, which translates to just about 3/4 of a hectare. So a hectare is a football pitch. So take the size of a football pitch where they play soccer there. If you watch my Liverpool versus Manchester United, where players play the game where there's grass, that's an equivalent of 1 hectare. Okay, so we are saying that if Lusaka was to be shared equally to everyone, everyone will get 3/4 of that soccer pitch. Okay, that's the population density. For Copperbelt province, we equally do the same, and we realize that if everyone on the Copperbelt province was given a piece of land, everyone will get about 0.011 square kilometer per person, which is just slightly over 1 hectare. Okay, so just about 1 hectare, slightly over a soccer pitch, everyone on the Copperbelt province will be entitled to that. So meaning that an individual on the Copperbelt province is more richer in terms of land, So if you wanted to go into farming, you're more likely to get a much bigger land on the Copperbelt province than in Lusaka because there's no land in Lusaka. Okay, that's a population density. When we are dealing with the species composition, we equally want to know how much species or what is the density of each species compared to other species. Using the same concept, we'll use this very same concept to calculate the relative density of species in an area. And I think this is one of the easiest way or easiest parameter to estimate, okay? So we have again plot 1, plot 2, up to plot 5. So in plot 1, we have species A, okay? In plot 2, we have species A appearing once. In the plot 3, there's no species A. In plot 4, we have species A. In plot 5, we also have species A. So we are saying species A is appearing how many times across the 5 species? It's appearing 1, 2, 3, 4. So we have 4. In plot B, for species B, we have 1 in plot A, nothing in plot B, we have 1 in plot 3, we have 1 in plot 4, and we have nothing in plot 5. So species B is appearing how many times? 3 times. And for species C in plot A, we have nothing. In plot 2, we have 1. In plot 3, we have 1. Plot 4, 1. Plot 5, 1. How many species? We have 4. Okay. What is the total population of all the species? We have 11. So we add 4 plus 3 plus 4 is giving us a total population of 11. That's the population. And remember, we're using the total population to divide from, the size of an area. So in this aspect, we have species A, which is 4, species B, which is 3, species C, which is 4. So again, we now calculate what? So we finish step number 1. Number of each species. Number of each species is 4, 3, 4. Step 1 finished. Step 2, We calculate the total population. So we add that, which is 11. And now we divide each species by the total population. Remember, we are calculating the population density. So we are saying for species A, we have 4. Okay? So relative density will be equal to the population of each species divided by the total population. So for species A, the relative frequency for species A will be 4 divided by 11. Okay? So if you get your calculator, you say 4 divided by 11, which is giving us 36, times 100. So the formula is relative frequency is equal to the number for every specific species divided by the total population times 100. So it will be 4 divided by 11 times 100. So 4 divided by 11 times 100. So we are getting 36.36%. That's for species A. For species B, we are saying it's 3 divided by 11 times 100, which is giving us 27.27%. The relative density for species C, it will be 4 again divided by 11 times 100, which is giving us 36.36%. Therefore, the relative density for species A is 36.36. The relative density for species B is 27.27. The relative frequency for species C is 36.36%. We are done with the relative density. It's much easier than calculating relative frequency. I hope that's clear. Let's move forward. We calculate the relative dominance. Which of the 3 species is more dominant? So when we are calculating the relative dominance, this is based on the basal area. The basal area is the cross-sectional area of a tree at breast height. So as a forester, for instance, if you are estimating species composition, tree species composition in a specific ecosystem or in a specific forest, you have to measure trees. So all trees, they are measured at breast height. Breast height is a distance from the ground to about 1.4 meters. So if you were to stand, an average height for a person, you stand, and then your basal area is just here where you have your chest starting, at the, where the chest, where, it folds like that, where your breasts start, in other words. That's 1.4 meters. So you take all measurements at that distance where your breasts start. That's why it's called breast height. It's at your breast relative to the height of a tree. That's where you do all the measurements. And that's corresponds to 1.5 meters. If you are in the UK where they use feet in terms of unit measurement, it's 4.5 feet. But we don't work with that in Zambia or in countries that were colonized by Britain. We use meters. So 1.4 meters. That's your breast height. So all measurements are taken from 1.4 meters. Okay. So at that very height, you measure the circumference of a tree. When you measure the circumference of the tree, then you do what? Then you calculate the basal area. And the formula for calculating the basal area is equal to basal area is equal to pi diameter, or dBH, which is diameter at breast height, squared divided by 2 times, or rather divided by 10,000 for us to convert it to square meters. Yeah, remember the circumference, you will get the measurement in centimeters. But now the measurements, you need it in square meters. So you divide by 10,000. For instance, if you've got a circle, if you've got a round circle, how do you calculate the area for that one? It's pi r squared, not so. So area of a circle is pi, where pi is 3.1416, something like that, okay? So pi times r squared, which is radius squared. That's how we calculate the area of a circle. But here we are measuring the circumference. We are not measuring the radius because we cannot see the radius. So we are measuring the circumference. So that's the diameter. So we use diameter instead of radius. And we know that 2 radius gives us 1 diameter. So that's why we are dividing by 2. Okay. Times, or rather divided by 10,000 to convert that to square meters. So that's the first thing you need to know, that relative dominance, we use it to calculate, or it's based on, the basal area. If we are working with animals, to some of you who are farmers, they will tell you that you estimate the basal area or the surface area of an animal by measuring the diameter just under the armpit. So you get your measuring tape or your diameter tape and measure the armpit there. That will be the diameter. And then you also get the full length of the animal, and then you multiply by some certain, constant to come up with the total weight of that animal, or the total circumference, as it may be. Okay, so for forest, we are saying that we want to estimate the basal area. So the basal area, for instance, okay, yeah, the basal area, in this case, if you have DBH, diameter to breast height, of 40 centimeter, okay, so it will be pi times 40, which is diameter to breast height, squared divided by 2. Then after the answer, you divide by 10,000. So if you multiply pi, which is 3.15 times, first of all, 40 times 40, okay, divided by 2 times 3.14, okay, divided by okay, yeah, so just follow through the example. We are saying pi so we divide a circumference divided by 2, which is 20. 20 times 20 is 400. 400 times 3.142. Okay, it's giving me 1,256.8 divided by 10,000, which is giving me 0.12568. That will be your basal area, square meters. Okay, so as you do your calculations, always remember you start by subtracting. Remember, from your mathematics, you have body mass, where it says brackets of division, multiplication, addition, and subtraction. So division starts first. So you divide DBH divided by 2, and then you square it, and then you multiply by pi, and then the answer you divide by 10,000, okay? You should be able to come up with a basal area of 0.1257. That's how you come up with the basal area. So again, you're going to get the basal area. So assuming you've got, in our example, where we had 4 species of species A. So species A, we had 4. Species B, we had 3. Species what? Species C, we had 4 as well. So we are saying if the total basal area for species A, for argument's sake, is 0.1257, then the basal area for species B is 0.0013. Then for species C, it's 0.01 for argument's sake. Then you now add that to get the total dominance, and then you now calculate the relative dominance by getting the basal area for species A. You get that times 100. You get that. You do the same for species B. You do the same for species C. After you finish now the relative dominance, you add the 3 parameters. So for species A, from our example there that I provided in the notes, you are getting 36.36 plus 36.36 plus 50. That was the total dominance. Under Appendix 1C, you were getting the total dominance of 50. If you add that, you find the sum, you are getting 122.72 for species A. For species B, you are getting 84.54. For species C, you are getting 92.72. The question is, which species has got the highest index? So you see that the higher the IV, the more ecologically important the species is in that specific community. So from our example in the notes there, if you look at Appendix A, Appendix B, and Appendix C, you will notice that species A has the highest index, which means that species A is the most important species in that community. What does it mean? It means that conservation efforts should be directed towards conserving species A. It also means that if we depleted or overutilized or overharvested species A, then the system, the ecological system, is likely to collapse. Okay, is likely to collapse. Species B is of the least important species in that ecology. All right, so why is IV important? Well, IV is important for 3, how many reasons did I provide? 1, 2, 3, 4, I think for 5 reasons. The first reason is that, the first reason why the index is important is that it identifies key species. It also identifies dominant, codominant, as well as rare species. So the species with the least IV is a very rare species. It also identifies keystone species. What we mean by keystone is an ecologically important species, which are essential for ecosystem health. So in our example, species A is a keystone species, because if we deplete, we do not conserve that species, the ecosystem will collapse, and provision of ecosystem will be normal. Provision of ecosystem services, that is goods and services, will be normal. It also guides conservation priorities. Okay, so when we use the IV, it will provide us with information on which species we need to prioritize in terms of conservation. It's also important in monitoring the ecosystem health, where maybe if we monitor this year and we monitor the same plot, the same site next year, and we see the IV value, maybe it's increasing for species, A, then we know that there is a signal of recovery or a positive ecological change. But if we notice that the IV for species A, it was 122 in 2020. In 2024, it's coming at 97. Then we know that there's a negative ecological change. It means that we are not using that ecosystem according, to the way we should. It's not in a sustainable way. It also provides us with information on resource management, okay, where we can actually say what type of harvesting do we practice in this area. Should we go selective logging or should we go reforestation so that we can see a positive ecological change? It also provides us with a baseline scenario where future monitoring, can be used to assess whether, we are doing well in terms of sustainable management of that ecology or ecosystem, or we are not sustainably utilizing that ecosystem by comparing biodiversity between different ecosystems and within, as in temporal changes, or by comparing it with one site maybe in Wansha and another site in Cherenge. So that is the important value index. And this is where we end our class. I need 2 more classes to actually be comfortable that you are ready for the exam. So we've covered the important value index. We have to quickly go into what is known as the Shannon Diversity Index. So we use another index to actually measure how rich biodiversity is in an ecosystem. And in our next class, I'll teach you on how to use the Shannon Diversity Index. And then from there, we'll look at a few, Environmental Management Act so that we appreciate, the authority that we use in Zambia and also at a global scale to conserve biodiversity. And then after that, you should be ready for the exam. I can rest assure you that in my exam, mathematical questions is a must. Yeah, I'm giving you enough clue. I hope you understand what I'm trying to say. Okay, I do not just want you to answer essays and define and blah, blah, blah. No, I want you to analyze issues using, metrics, using the index. So you have no option, but you need to know this. In other words, if you do not know how to use the important value index, you do not know how to use the Shannon Diversity, index, then you cannot pass this course. It's as simple as that. Okay. So you need to know this like the back of your hand. We'll end here. I will share the recorded version of this class and I wish you well. Thank you.